In this video, we're going to create a G-code program using the SketchPad and then show you how to import it into the tree so that you can make it part of your G-code program. We're going to use the SketchPad. We're going to import a Dxf file and then create the G-code program from the Dxf file. So we're going to open up the SketchPad and then we're going to go and get our Dxf file that's in our SketchPad folder. And you can see from the list is that we have the elements brought in and then the drawing up on the screen. A couple things that you need to remember when you do a Dxf translation is that the SketchPad needs the individual elements that comprise the drawing. And sometimes if you create a drawing and use blocks, or if you use polylines, you need to use the explode feature in your CAD program that will take those blocks of elements and make them into individual elements. So before you export the Dxf file, you should use the explode feature in your CAD program to make sure that you have individual elements. The other thing to remember is that there's no way to really change the part 0 location in the SketchPad. We rely on the elements that they're in the correct position when you export them. So you want to make sure that before you export your Dxf, you've moved the part so that the 0, 0 point in the CAD program is the same that you want it to be, the 0, 0 point on the part, so that when the elements come in, they have the correct coordinates. In order to create a program from a shape or from the Dxf, we need to be able to find the start point of the contour and the end point of the contour. And the start point of the contour has to be going in the direction that you want the cutter to go around the part. So in this particular case, I want to start on this lower right corner and I want to go up and around counterclockwise around the part. So what I'm going to do is I'm going to find that element in the list, and here it is, but you can see that the start point is here. The circle designates the start point of the element, and I want the start point to be down here. So I'm going to select the element and then I'm going to change the direction of the element by hitting this icon here. And now you can see the start point is here. So when you click the elements in the list box, they turn yellow, and in order to make it the element that I want to start my contour with, I need to tell it that this is the start point of the contour. Now I need to find the ending point of the contour, which would be a line going this direction, and tell the software that this is the ending point. So I have the start point, ending point. The software will automatically close the contour loop and create the G-code program. So once I have those two connected, I can start my milling program, fill in the blank form, and what I'm going to do is I'm going to give it a rapid plane of 1 inch. Part 0 is the top of the part. The coordinate of the bottom surface is minus a half an inch, and the coordinate of a clearance point is 100. I'm not going to use a tool call or a post call because I want this to be just a little subprogram so that I can use put it into the tree and use the create main program feature to create the program. So I'm not going to call out a tool or a height. I'm going to call just the RPM and then go through and give it my depth of cut, which I'll give as 100 thousandths in Z. I got a ½ inch cutter. My plunging feed rate would be 20. My cutting feed rate would be 12. And then I'm going to use cutter compensation. So I'm going to give it an offset of 22. And then I'm going to select an approach direction. So this is going to help me for the software to automatically put the lead in into the program. So I'm going to come to the part from this direction. Another thing to remember about Dxf files is that the precision of the Dxf file sometimes can be a little erratic, and what you'll find is you'll make a program and it'll stop midway around the contour. That's because the 4-place decimal points just don't quite add up. Sometimes they're off a tenth or two, and the software will miss the connection between the elements as it's connecting them together. So one way around that is to change the precision when joining elements to 2 places. And this will force the SketchPad to look a little bit closer at the elements to make sure that it connects them all. So I've got my fill in the blank form completed, and I'm going to hit Create Program. SketchPad goes through, automatically creates a little subprogram. 100 thousandths depth of cut automatically turns my cutter comp on and off, and so this is the G-code program to machine that shape. I'm going to use this icon with the arrow in it to save this as a KipwareM operation. I'm going to save the file as contour2, and I'm going to see that it's saved, and now I can load it into the Kipware tree. So I'm going to close out the sketchpad, and then I'm going to use my operation to open the operation. I'm going to get contour2 and put it to the tree. And now I can use the create main program feature to use that contour2 as part of my program. If I want to see what the toolpath looks like, I can open up the plotter and I can plot the toolpath. Let's move it over so we can see where it's going. And you can see from the Z vision that I'm going down 100 thousandths each time, going around the part of the contour that I defined. So that's how you create a program using the sketchpad, and how you bring it into the tree. One thing to remember is when you do open the editor on the sketchpad, that we want to use this icon here that says Save as KipwareM Op. And what this will do is reformat the program to make sure that when you bring it into the tree, that it's got the correct format to be able to be built using the Create Main Program feature in the software.